In this video, we will be covering a variety of database concepts and terminologies that will help you understand systems that store and manage data. These concepts will also help in the understanding of the structured query language and the kinds of items and elements on which it is used. The structured query language is tied very closely to the concept of data modeling and data models. What is a data model? A data model is a graphical representation of our understanding of organizational reality. It is a way to visually represent different elements and it is a way to visually represent different elements of data that may be present within an organization and how these elements of data may be related to each other. One of the most common forms of data models is the relational model. The relational model is a system of notation that allows us to describe the relationship between different data elements in particularized ways. SQL is a language that allows us to take the data model that is built and make it real. In a way, concretize it through programming into a database system. SQL, or the structured query language, is considered both a data definition language and also a data manipulation language. By a data definition language, I mean that SQL allows us to establish rules and by data definition language, I mean that SQL allows us to establish a specific structure for the elements of data that we want to store. It establishes specific data types, it establishes specific constraints, and so it really allows us to define the structures within a system that store the data. As a data manipulation language, SQL offers us a variety of statements that allow us to manipulate the structure of data. It allows us to manipulate the data itself and also the structure of data. SQL is data independent, and by that I mean that SQL works regardless of the type of data it is working with. Now we will cover some concepts and terminologies associated with data models and the corresponding terminologies and concepts in a database. The first concept we should familiarize ourselves with, associated with a data model, is the concept of an entity. An entity is something in the environment that we want to keep track of. This environment can be an organizational environment, this can be a social environment, really anything typically that we want to keep track of. For instance, we would represent as an entity. Some common examples of entities at a university could be students, faculty, courses, buildings on the campus, departments. In a college, a variety of colleges at the university. These are all examples of entities that we may want to keep track of. An entity in a data model is typically represented by a rectangle or a square box of some shape. An instance is a specified occurrence of an entity. For instance, one student is separate from another student. Each student is an instance of the entity student. When we take this concept of an entity over to a database as we physically instantiate it, a table in the database corresponds to an entity. Typically, the name of the table corresponds to the name of the entity in the data model. Now, names of tables have to be unique within the database as we don't want um, the system confused or muddled up with tables having common names. In fact, most systems don't allow multiple tables to have the same name. Names of table are unique within the database. Very frequently, we will come across conventions or rules that typically must be followed when we have names of entities or names of tables. Table names typically start with a capital case letter. Another important concept associated with the data model is that of an attribute. An attribute is a discrete data element that describes an entity. An attribute is a fact that we wish to know about the entity. Think of some common facts that we might want to know for a student, for instance. We might want to know the student's first name, their last name. We might want to know a student's year of graduation. We might want to know a student's major. We might want to know the student's date of birth. These are all attributes of the entity student. Now, attribute names must be unique within a data model. Attribute names must also be meaningful. By meaningful, we mean that attribute names need to be easily understood. When I refer to date of birth, it needs to be understood what that attribute is referring to. Consequently, having meaningful attribute names is important. When we take attributes and convert them or instantiate them, attributes of an entity correspond to the specific columns that exist within a table. The names of the attributes correspond to the names of the columns. And these column names are unique, in fact, have to be unique within a table. Typically, according to convention, column names start with a lowercase letter and use camel casing. What does camel casing refer to? Take, for example, the column date of birth. Date of birth, in fact, is 3 words, date of birth. When used as a column name, date of birth with no spaces between them, this column name starts with a lowercase d and a capitalized O in the word of and a capitalized B in the word birth. And so that refers to camel casing, where we start off with a lowercase letter and every word in that column name starts with a capital letter. Another important concept associated with data models are identifiers. Identifiers are a way to uniquely identify every instance of an entity. It is a way that we can distinguish, for example, one student from another student on a college campus. An identifier is typically an attribute or collection of attributes of the entity. An identifier, or the attribute that is used as the identifier, is signified with an asterisk because it has a special purpose. Identifiers, when converted to table form, are referred to as the primary key of the table. The name of the identifier corresponds to the name of the primary key. Very frequently, we may find tables that have more than one column as that primary key, and that is referred to as a composite primary key. You may think of some common attributes that might serve as identifiers. For instance, your student ID number might be a common identifier. Your social security number might be a common identifier. Last names, however, make very poor identifiers on a college campus. One of the reasons why last names make very poor identifiers on a college campus is because multiple individuals can share a last name. Consequently, each student cannot be uniquely identified by using their last name. Another important concept of data models are relationships. Relationships are how one entity is related to other entities. There are several types of relationships that can exist between entities. Two common ones are one-to-many relationships and many-to-many relationships, details of which will follow later on. Here are some terms that we need to become comfortable with as we are working through SQL and data models. The first term is that of a database server. A database server is really a collection of databases. A database server is a computer that is running a specific type of software that allows an organization or an institution to store multiple databases on it. A database is a collection of related files or tables. Records are rows in a table. Each row represents one instance of data. Fields or columns are fine details of an instance. They are facts about the instance that we are storing. There are many different data types that are supported by most common databases. Every column has a specific data type, and here are some common data types that can be used. Obviously, this is a partial list, and a whole list depends on the type of database server being used and the type of database being used. Very frequently, certain types of data need to be encapsulated within codes, and there are three types of codes that can be used: the single, the double, and the backcode. The first two types of codes are interchangeable typically, especially in MySQL, the system that we're going to be using for this course. This completes the topic on database concepts and terminology. Please let me know if you have any questions. Thank you very much.